Now, as we start Chapter 3, or Unit 3, keeping in mind this has been a compilation of a number of different topics, we will do 2 lessons today. Since this is the one day we do 2, we'll be doing 3.1 and 3.2, dealing with sets, symbols, and terminology. Going on to our first item, now we need to keep in mind the background material we had in our flipped classroom lesson. So here, a little quick review in terms of what we call set notation. Here they're describing the set. So that's one way to denote set notation. But this one is in particular what we call roster notation, where we list the elements or members of the set. So look at these. You're going to have to read these through and see which statement supports this roster notation. And you should have picked out letter B. All right, let's go on. Now, another form of notation is what we see illustrated here, where we have a brace, x. X is such that x is a positive integer, power of 5. Now, when it's listed in this form, this is called set builder notation. Again, the previous one was roster, and we had set notation where we're describing, but this one is called, in this form, set builder notation. And you probably should write that down. Now, what are they asking? Well, it's going to be powers of 5. So we start off with 5, and that's to the first, because we're looking for positive numbers. Then 5 to the second, then 5 to the third, and 5 to the fourth. And they want us to put these as integers. Well, this would be an integer. 5, we don't usually write the 1, but then we would have to convert this to 25, and this to 125, and 5 to the fourth is 625, and then it continues. And if you recall, these 3 dots indicate the pattern continues, and this is called the ellipsis. So which one of these would you fill in? Now there's only 4 slots here, so we have the 4 numbers here, and then the ellipsis. So if you said D, that would be correct. So you would put 5, 25, 125, 625, and then your ellipsis. This would then be in roster notation. Once again, like this, set builder notation. Like this, roster notation. For number 3, take a moment, read them over, and see which it would be. And I believe D would be the answer here. I don't know if these others are true or not, but this looks like a good one. Zodiac signs that begin with L. Now, for number 4, we are asked whether or not this is a finite or infinite set. And in set builder notation, the statement is x is such that x is a natural number greater than 40. Now, can you give a specific number for this? Or does this go to infinity where there is no specific number? Well, it goes to infinity, so there's no specific number. And now they're asking you to match up which one would you select. And it looks like C, because you cannot give a whole number as an answer. So this set is infinite. Now for number 5, they're asking us to find this of set A. Now notice set A is in roster notation. It is finite. The use of an ellipsis in there indicates the pattern continues until it gets to Z. So what are they asking here? Well, this refers to cardinality of a set. That is, how many elements are in the set. And what do you say? Again, there's 26 letters in our alphabet, so this would be 26. Now, for number 6, they're asking, determine whether the set is well defined. Now, notice it is in set builder notation. Read these through and see what you can find. I believe D is the answer. It is well defined because membership can be clearly determined. It's going to be a negative whole number. Now, an interesting thing about this is as you look at this, are there any members of this set? Well, are there negative whole numbers? Remember, whole numbers start at 0, 1, 2, 3, and then continue on to positive infinity. So this, even though it's well defined, would be considered an empty set. There are no elements. And we said another way of writing that is with a O with a slash through it, or it's a null set, that there are no members in it. All right, they kind of slipped that one in there. So in number 7, we're looking at this symbol and then this symbol. This is an element of the set. This is not an element of the set. So take a look. You want to make this statement true. Which would you pick out? And it looks like letter C. The symbol is not an element should be used because 2 is not a member of the set. All right, for number 8, we'll pause to read the statement. Is this statement true or false? And then which one statement below supports it? Well, it's letter D. The statement is false because the set on the left has one element, 0, while on the right, it's saying the set is empty. So that one's a little tricky. Read it carefully. All right, let's go on. Number 9's an easy one, I think. Read it carefully. And is this statement true or false? Well, it's true. 5 is an element of this set. All right, let's go on to our last one. Two sets are equal if they contain identical elements. Two sets are equivalent if they contain the same number of elements, not necessarily the same elements. In the following condition, give an example to explain why it is possible. Two sets are equivalent but not equal. Well, here you have A, B, C. A, B, C. Order is not important, so these would be equal. In B, if they are equivalent, they have the same number of elements and must be equal. No, that's not true. This is possible in the example A, B, C. This has 3, this has 4. That's not true. This is possible. An example would be this has 2 elements and this has 2 elements. So these would be equivalent but not equal. Okay. So the justification of this is letter D. All right, we're going to go on now to topic 2 because these are done in the same class. All right, as we go into topic 2 now of unit 3, Venn diagrams and subsets. So once again, you've worked on your flipped classroom video, have those notes. That was background and examples. This is a review of our homework examples. So looking at number 1, we're asked to describe what is listed here. Now, these are all subsets. Notice the set notation and roster notation. So we have P, Q, PQ, and then this is that empty set, the null set. Now, a null set or an empty set is a subset of every set. So take a moment and see which one you can match up with. And the answer is C. Now, how many elements are in this set? 2. So the rule for the number of subsets, as a little review, is 2 to the number of members or elements in the set. So there are 2 elements in the set, so this would be 2 to the second power. There would be 4 subsets, and here we see them listed. Okay, let's go on. Now, as we review symbols, kind of an elongated C, this is a subset. This is also a subset. So what's the difference between these two? Well, this is a proper subset, and this is just a subset. And we need to put subset here as well. Now, a slash through it is it's not that. So here we're asked, which one of these symbols would we put here? Now, the set is Wednesday, Thursday, Friday, Saturday, Sunday. Notice Tuesday is not included here. So this subset is not a subset of this set. Now, looking at number 3, again, you're copying this down. What symbol are you going to put here? This is an empty set, is a subset of this. Is it this symbol or this symbol? Well, we said that an empty set is a subset of every set. So this would be the answer. All right, let's go on. Now, looking at example 4, and keeping in mind what we said about this symbol, this is a proper subset, and this one is a subset. Now, the formula for a proper subset is that it's 2 to the number of elements in the set, but it has to be at least one less than what's in the set. So where a set is a subset of itself, for it to be a proper subset, it has to have one element less. So as we look at this, set U is this, set A is this, and there is a K and a P. So this is a subset, but is it a proper subset? Does it have at least one fewer element than this? Yes. Now, which letter then does it match with? And it's C. It's true because set A contains in set U, but set A does not equal the number in set U. It is a proper subset. All right, in number 5, we're looking at set B and then set D. Now they're saying, and you have to know how to read this, D is not a subset of B. Now notice where both sets contain a D, set D here also contains an F that's not found in B. So is this statement true? Is D a subset of B? No. So this statement is true. Now, which of these will you check? And if you pick D, that is correct. The statement is true because not every element of set D is contained in set B. Now, throughout this unit, we'll be looking at statements to prove their validity. So again, time, patience, careful reading, understanding the symbols, knowing what they stand for and how they're used will be an important skill. Now, for number 6, background would be, how many subsets does this set A have? Well, the formula for subsets we said was 2 to the n power. And then later, how many proper subsets? That would be 2 to the n power minus 1. So we count the number of elements, 1, 2, 3, 4, 5, 6. And we get 2 to the 6th here. And then 2 to the 6th minus 1. Now what is 2 to the 6th? Well, this one is 64. And then 64 minus 1 is 63. Okay. Again, if you have a question, be sure you're asking. Now, for number 7, we want to find the number of subsets. Again, that would be 2 to the n. And then proper subsets, 2 to the n minus 1. But here they're giving us a set builder statement. X is an even natural number less than or equal to 5. So we have to define our set in roster notation. So an even natural number would be 2, 4, and it's less than or equal to 5, so 5 wouldn't be in it. So the number of elements in our set here is only 2. So this would be 2 to the 2nd, which is 4, and 2 to the 2nd minus 1, which would be 3. So here we're only giving part of it, but you'll, on your homework, if you get one like this, they're going to give you a B option later. Now in number 8, we're going to see this often in working with sets. They want to find the universe of the sets. That is the listing by letter of the different kinds of trees, but we only list them once here. And chances are you want to put them alphabetically. So go through this in your paper, list these, and see if you end up with what I end up with when we finish. Did you get something like this? And again, you want a strategy for doing it. So I kind of scanned both lists and I saw the A was first. So I put a slash through that. Then I looked through the list and I got a C. Put a slash through that. Then a D. But I saw a D there. Then I had an H. And notice I had a hickory on this side and a hickory on this side, but I only wrote the H once. So this would be the universe, that is the combination of the trees in both parts. That is the smallest universal set U.